Good afternoon, everyone. Welcome to our presentation on monitoring the London Underground. My name is Adan Mohamed. I'm the DevOps manager at Bolden Networks.
And my name is Nathan Liefting. I'm a Zabbix consultant and a Zabbix trainer. I work for open source ICT solutions, where I provide consultancy, training, and anything you might need on Zabbix full-time. As well as some of you might know me from the Zabbix books, which actually I am pleased to announce that we are writing Zabbix 7 already, almost done, waiting on a few more features to finish it up. So that's coming too. Thank you.
Thank you very much. I work for Bolden Networks. Bolden Networks is a multi-sited company based out of London. We also have offices in the US, Hong Kong, Italy, UK, and Ireland. We have 6 major transport networks, over 300 neutral host venues, and over 120 small cell assets. We have been awarded the Transport for London, Transport for London has awarded us a concession to build a connectivity network in the London Underground. This will cover 136 station platforms and over 400 kilometers of tunnel, including the emergency services network. With this, we have 10 Edge Delta data centers, base station hotels, we like to call them, strategically placed all over London. We also have 400 kilometers of underground tunnels, including the TfL public Wi-Fi. This encompasses 120,000 small cell locations, including stations, lampposts, bus shelters, etc. Now, when it comes to installations, you can imagine we need to get into the tunnel and physically lay down fiber optic cables running right along the tunnels. One of the challenges we face is that the trains stop running around 1 a.m. They then start up again around 5 a.m. So literally we have about 3 hours to get hundreds of engineers into the tunnel, lay down this fiber cable, and then get out again before the trains start moving again. With this, we have 136 stations, platforms, over 400 kilometers of tunnel network to allow this whole network to work, basically.
Cool. And then I'll tell you a little bit about the Zabbix installation, because all of this, of course, has to be monitored. So all of those small cells, everything that's in the tunnels, we have to make sure that they are up and running, that the guys at Bolden, their NOC engineers, their second line, they all need to know about, hey, what's going on with that hardware? We need to keep it up and running. So one of the important decisions in the design we had to make is, of course, high availability. Now, we're running this in the cloud, so we have to make a few key decisions. First of all, you might see there's a few load balancers involved. When we're running this on hardware, normally I like to keep them out of that. But to keep things simple, at the bottom you might see we have the Zabbix servers directly connected to the databases. No load balancer there. Cool thing about that is because Zabbix keeps everything in that database, that high availability, the heartbeats, we can make sure that if there is a failover, Zabbix knows, even though they're connecting to one database, and we make sure to do that with the databases in a primary setup using MariaDB and Galera. Web frontends, they don't know which of the databases is online, so they will communicate in the cloud through a load balancer, which will check which database is still running. If there isn't one, it will fail over. And of course, we have a load balancer at the top to make sure that when you are connecting to a front end, you're connected to either one, load balancing the load there, as well as if there is an outage, making sure that we don't have an issue with that. And then within the tunnels, within the base stations specifically, there's also some hardware that has to be monitored. So to do so, we will use proxies. One proxy per base station hotel, where we make sure that we collect the data locally as close to the source as possible. As well as you might see in base station 3 and base station 5 over here, we have 2 proxies. And those 2 proxies are part of a kind of cluster. Because we can make sure, just as was already mentioned by InitMax this morning, we can make sure that we can do a failover between the proxies. So what we do is quite similar, actually. We've been doing this for a few years. We make sure that in the front end we add the tags that we will use in an action when a problem shows up. So you might have a proxy going down, or you might have a virtual IP switching from one proxy to the other. And in those cases, you want to make sure that all of the hosts that are being monitored by that proxy do a failover. And when they do that failover, we also make sure that we reload the configuration cache to make sure that the failover is done within a few, like 30 seconds, maybe up to a minute. So, pretty similar over there. And there's a few more things we actually have to keep in mind. When we are working with so many different devices, it also means that we have to keep things simple, and we aren't just collecting or adding all of these hosts manually. And actually, to do so, we've done a few interesting things. Network equipment is all just hosts being added, so you have your switches, you have your routers, we add them, we do SNMP on them, just like you would expect. But for the cellular network equipment, as well as the cabinets and the optical network equipment, all of that is being sent to a kind of management platform where we have an alert collector. The alert collector will make sure to collect all the alerts, create events from them, and then stream them right into Zabbix with SNMP traps.
So this here is a high-level architectural diagram that just shows how everything is kind of laid out. At the bottom, we have our fiber optic cable that runs along the tunnels. This then provides us with commercial mobile services and the emergency services network, as well as providing connectivity to the tunnels and the stations. The fiber then comes up onto ground level and provides connectivity to all the stations, as well as small cells to lampposts, bus shelters, etc., as well as other smart buildings and venues, stadiums, and then that then goes up to the cloud, and then it provides our monitoring services, and our NOC and SOC can then access that information and make sure that everything is working.
All right, so SNMP traps. Like I said, we have quite a few alerts coming in. Thousands and thousands of devices, all sending that to an alert collector. And this is unreadable. We'll go to the next slide in a bit where we can see it a bit better. But the important part here, we have an item. That item is collecting all of the SNMP traps. About all of the alerts on the alert collector, specifically in this case for the cellular devices. We catch those traps with the regular expression in the key, and then I use 4 triggers, 1 per severity that we would like or that we are able to receive. And we only need that single trigger to create every single alert. Thousands, tens of thousands of alerts coming into Zabbix. How do we do that? Well, we have to use the macro functions. The macro functions are all powerful in this case and super useful to do something like this. Make sure to enable multiple event generation mode, and then we make sure that our trigger name and specifically the event names are going to be dynamic. Now, we have a macro, the item value. The item value will contain the entire SNMP trap that we need. All of the information that we are receiving from the alert collector. So think about where did it happen, specifically what device, what's the path to that device, and what severity, for example. And is it an alert that just started, or did it resolve? But we still have to extract that data, and we do so by using the rec sub macro function. That macro function will include a regular expression